Hello world, Joe Strout here with another coffee break coding. Today we're going to take a look at tweetcodes. A tweetcode is a short program, so short in fact that it can fit inside a single tweet. So here's an example. When run it looks like this, and this is the actual code. A tweetcode can be pretty dense because an entire program has to be crammed into the 280 characters. So today we're going to look at how to take one of these programs that you might find in a tweetcode and break it down and figure out how it works. I've got a few queued up here, and the one I want to take a look at is this one. This is the most recent tweetcode that I did, and you can see that it makes this pretty spirally graphic effect. So how does that work? If we show the thread, here's the actual code. And I'm going to start by copying this code. And we'll go over to Mini Micro. Let's use reset to make sure that the program is clear. Of course, if you've just booted Mini Micro, that's not really necessary, but it never hurts. And then edit and paste in the code. Now the first thing that we'll notice is a lot of tweetcode programs have import TC at the top. TC is a module in the syslib directory that's specifically for supporting tweetcodes, and it defines shorter names for a lot of things that are normally a bit longer. So we're going to go take a look at that. Close this, and we'll go to syslib, and here you can see the TC module. Let's just load that up and have a look. All right. So there's a lot of small helper functions in here. There's something called 1to, which is a shortcut for range from 1 to a number. There's functions for drawing and framing rectangles and ovals and making circles. There's a clear function, which clears only the graphics display. And then there's this function called flip. This one is actually used in the tweetcode that we'll be looking at, as it is in a lot of tweetcodes, because flip is a really handy function. What flip does is it switches between two pixel displays so that you can draw in an off-screen display and nobody can see that drawing happening, and then you just flip to a second display so that you're drawing on the new off-screen display and the one that you were drawing on now becomes visible. So you just flip back and forth between these two graphics pages and you can draw whatever you want without any flicker because no one ever sees you erasing to draw something new. This is a function that we'll see used in the tweetcode we're going to look at today. And then there's some other miscellaneous aliases. There's pi, the character pi as a shortcut for the built-in constant pi. There's also tau, or the symbol tau, which is equated to 2 times pi. These are both really handy when you're doing trigonometry stuff or anything involving circles and triangles. There's a palette of our 20 standard colors, there's a function to load an image, and so on. A lot of this stuff isn't used in this particular tweetcode, but it's nice to know that it's here. So if we close that, reset, edit, and again paste in that code that we copied off of the tweet, now here it is. So it starts with import TC. Now this particular tweetcode actually has line breaks. A lot of times there are no line breaks. Everything is just jammed together with semicolons because you can always do that. You can put a bunch of lines together in one just by using semicolons instead of line breaks, and then you're not spending anything on the indentation that is automatically added. But when you're trying to understand code, it's usually much better to separate each statement out onto its own line. So I'm going to start by putting in line breaks in place of these semicolons. And while 1 is normally written while true, just to make an infinite loop. They do the same thing. In a tweetcode, obviously, we use while 1 just because it's 3 characters shorter than while true. Here's that flip statement and a yield. You often see these together. So here you can tell right away that this infinite loop is doing some kind of drawing, and it's using this page flipping technique to ensure that you never see it erase. And this is gfx.clear. Now we actually could have used the CLR function that's in the TC module, and I think that would work the same way. But because in this tweet I actually had characters to spare, I just used gfx.clear. Now we've got this R variable, and when you're trying to understand a tweet code, figuring out what the variables actually mean is really key, because usually the variable names are really short. So we're going to come back to that. We'll figure out what R and IR mean. I'm going to insert some spaces just to make it a little bit more readable for me. Then there's a for loop for I in range 1 to 100, stepping by 2. So that means it's going to go 1, 3, 5, 7, all the way up to 99, not quite reach 100. And for each of those steps, we do these 4 statements. We set b width, and what is b? B is a bounds object. So we're setting the width of the bounds to I times 7, the height to I times 5. We're setting a rotation that depends on this R and IR. And then we're calling gfx.drawPoly with the corners of the bounds. So now that we've kind of gone over this and we've neatened it up a little bit, let's run it and see if we can understand what's happening. Well, you can see it's drawing a bunch of rectangles, and if I stop it, it's actually easier to see. It starts off with a tiny little rectangle in the middle, and they get bigger and bigger. And as they get bigger, they rotate, and they change color from green to red. So let's take another look at the code. Okay, so we're setting the rotation here to R plus I times IR, and those are the only places that R and IR occur. So I think we can start to figure out what these variables mean. R is the overall rotation, which only changes in this outer loop. It changes by 2 each time we draw a frame. So we're going to call this overall rotation. And then IR gets multiplied by I. So this is going to make it, within this inner loop, a different rotation for every rectangle that we draw. So this is the rotation step, or another way to think of this is the amount of spiral, because it's this changing the rotation as we draw bigger and bigger boxes that makes it spiral around. And initially this IR is 0, which means we're multiplying I times 0. That's obviously not adding any rotation at all. But the amount of spiral increases on every frame as well. So it's going to start off not at all spirally, and it's going to get more and more spirally as time goes on. And again, when we think we understand what's going on, always a good idea to run the program and see. So yeah, it started off without much spiral, and now you can see that spiral is twisting tighter and tighter. And that would be because we're adding a little bit to this IR, this amount of spiral on every step. Now this for loop is drawing a polygon, in this case a rectangle, for every step from 1 to 100 in steps of 2. If we were to make this steps of 25, then there should be only 126, 51, and 76. If we just add 25 each time. So if we run this, there we go, 4 rectangles. And the size of these is 1, 26, 51, and 76. So that's what this for loop is doing. We'll put it back to 2 because that makes for a prettier spiral. What else can we mess with here to make sure that we really understand? Okay, let's consider the colors. The color of each rectangle is determined by this RGB second parameter to draw poly. RGB takes a red, green, and blue, each in the range 0 to 255. So what we're using right now is I times 2, 200 minus I times 2, and I for the red, green, and blue. So this is going to give us an amount of red that increases as we go from 1 to 100, an amount of green that decreases as we go to 1 to 100. So as we go to larger and larger rectangles. And then the blue is going to increase with the rectangle as well. but not as fast as the red. So let's see if we can break this down and make it a little bit simpler. Let's look at just the red. And since I'm going to be messing with this code pretty heavily, I'm going to copy the original line and just comment it out with 2 slashes. Now we can safely change the green and blue parameters to 0. And here's what it looks like with just the red bits. It starts off very dark in the center, gets brighter to the outside. Now let's try setting red to 0 and looking at just the green. 200 minus I times 2. Here's the green part, very bright in the center, gets dark on the outside. And last, let's look at, just the blue part, which is I, and it's going to be, so it's going to go from 0 to about 100 as we go to the outside. That might be hard to see on the video, but it starts off black and then it goes to a pretty dark blue around the outside. And so if we put them all together, we get the original colors. And to really make sure we understand this, let's try making a different color pattern. Let's say we wanted it to be yellow in the center and go to a blue on the outside, a strong blue. Well, to get a strong blue, if we're only going up to 100, we need to use some factor that gets us closer to 255. So if we multiply I times 2.5, then when we're near 100, this will be around 250, which is a pretty strong blue. To make yellow, you mix equal parts of red and green. So let's start with 255 minus I times 2 for both red and green. And that should be yellow in the center, fading to blue on the outside. Let's try it. Hey, there we go. So thanks for watching. I hope you found this interesting. And I hope now when you see some dense code in a tweet code or wherever it might be, you know how to break that down and figure out how it works. To learn more about Miniscript and Minimicro, go to miniscript.org. There's all kinds of useful information here, including links to the community that you'll find on Discord or in the forums. You can also follow the links to Miniscript books, Learn to Code in 30 Days, and there's another one, Introduction to Computer Programming, which is getting so close it'll probably be out in another month or so. While you're there, you can go to Miniscript Press and check out our merch, where we also have cool t-shirts and pop sockets. Every penny goes to support further development of Miniscript and Minimicro, so I hope you'll help us out. So that's it for this week. Happy coding!